A general system bus, or any system bus, is conceptually just a collection of wires shared by all components, and it usually allows the communication between several of these components. And particularly, we're going to see that it allows exchanges of data between a processor and some memory modules, or maybe the processor and a bunch of I/O cores in here. So in a very, very simplistic setting, you're going to see that the processor functions as the master or the primary, and the memory modules or the I/O cores, they function as the slaves or secondary. So what I'm trying to say in here is the processor usually is what initiate all of the commands. So it initiate read or write processes. The I/O cores in here, or even the memory locations, cannot initiate the read and write. So a processor would request some read from RAM or from memory and so forth, or it actually can request a write into it or write into it without a request. And specifically, you will see that the bus, or these wires that constitute a bus, are generally categorized into three groups. And these are generally data lines, address lines, and control lines. So data lines just carry the actual data that you want to transfer between the processor and the RAM, or the processor and the I/O cores. And in our systems, we will see that we have two different types of data lines, and these are the read data lines and the write data lines. And the width of which of these data lines, for example, if this is actually 32, that tells me that the word length of that particular processor is about 32. Of course, this is not the only way, but generally speaking, you're going to see if it's 32, we consider that processor to be 32 bits. And this is what we will have. We will have a read line or read data and write data. And similarly, we have other ones which are called address lines, and these are what we see in here. And the address lines allow us to specify which location in memory, or actually which I/O core we want to communicate with, or we want the processor to communicate with. Not only this, it also specifies which internal register within the I/O core I want to communicate with, and this is usually embedded within the address. So the processor places an address in here that indicate what place or component in the I/O memory or the memory map that it wants to communicate with, and then it starts initiating that communication. So the last category, which is control lines, generally speaking consists of command or status signals. So we will see it contains maybe read signal, write signal, ready signal, some handshaking signals, depending on the system you have. But in any case, any system consists of these three different categories for the wires that constitute a bus. So this particular view is very, very simplistic. A practical bus is actually a lot more complicated. And one of the buses that you might want to take a look at is actually the ARM AXI, or Axibus. And the Axibus Protocol is a distributed communication infrastructure or interconnect, and it's a lot more complicated than this. It allows, for example, a master to connect to multiple slaves and vice versa, and the different slaves to communicate with different masters and whatnot if you have different processors on board or different cores. However, it's too complicated for the purposes of what we're trying to do. We're trying to build a system from scratch, and we don't want to pick something off the shelf and just plug it into our system. We just want to build it from scratch, and I want you to get a feeling of how a bus actually works and how we can translate between the different buses. So we will adopt this particular simplistic approach in here, which might create some bottlenecks and slowness and so forth. For example, if one of the I/O cores just occupy one of the read or write or the address bus, nothing else can happen. The processor can't communicate with anything because the I/O didn't release it.